Alright, well, ready or not, here we go. Today is October the 7th, 2019. Today is National Inner Beauty Day. So, Inner Beauty Day today. We are talking about polygons. That would be the title of today's notes. Polygons. The joke of the today is, you want to know who I saw yesterday?
Everyone who looked at.
Everybody I looked at. That's the joke of the day. Lame, I know. Okay, so we are going to be focusing on polygons today, and actually the focus for today is not just going to be what a polygon is, but we're going to be focusing on the interior angles of a polygon. So, in other words, we are going to be talking about polygons first of all, and then we're going to be talking about exclusively the angles on the inside of a polygon. Today's the inside day. Tomorrow we'll be talking about the angles on the outside of a polygon, but we're doing the inside first. Okay? Alright, so first of all, a polygon. Let's make sure everybody knows what a polygon is. Alright, some of you may be able to break down the word polygon. So anybody know what the prefix poly means? Many. Yeah, so poly means many. And then if a word ends in gon, G-O-N, sides. Many sides. So in the most rudimentary sense of things, the most elementary sense of things, a polygon is a many-sided shape. All right? Awesome. But we have to know what makes a shape a shape. Like what makes this, okay, there has to be more than that. It can't just be like, really, Mr. Jenna, that's it? Many sides, that's what a polygon is. So let me ask you guys, what do you think? Do you think a polygon has to be a closed shape? Yes, it does. Okay, so let me give you guys a couple of visual examples of shapes that would be not polygons. Okay, so this shape right here that I'm drawing would be not a polygon. Why would that be not a polygon?
It's open.
It's open. It's not closed. Okay. I like how you guys thought positively there. You said it's open. I would have said it's not closed. You guys are optimists, not pessimists. I like that. Okay. All right. The next one. This is not a polygon. Anybody know why that one would be considered not a polygon? We are recording information right now. You just gotta sit down. Come on. Guys, hey, hello. Why would this be considered not a polygon?
Because there's only one side.
Well, technically, is this curved part considered a side, do you think?
No, sir.
No. Okay, you guys, curved parts are not sides. So, in order for something to be considered a side, it has to be what? Straight. All right? Now, you may be asking yourself, hey, Mr. Chutna, how come a curved side, how come a curved part is not considered a side? Here is the answer to that question if you were wondering that. I just attempted to draw what? A circle. How many sides does a circle have? None. So a circle is not a polygon. Why? Because the sides in a polygon have to be straight. Okay. So you guys have pretty much defined a polygon for me, even though you don't know that you defined it for me. A polygon is this. It is a closed, straight, sided shape with at least, how many sides does a shape have to have in order to make it closed? Like, what's the minimum number? 3. So it is a closed, straight-sided shape with at least 3 sides. Okay? So any shape that is closed, all the sides are straight, And if it has at least 3 sides, it would be considered a polygon. Okay? None of these right here would be considered polygons. So there we go. We got a definition for polygons right there. Will you guys ever be tested on, hey, what's the definition of a polygon? No. Not in this class, at least. Maybe in some other class, but not in this class. All right? But you do need to have an understanding of what a polygon is. Why do you have to have an understanding of what a polygon is? Because I will be mentioning that word rather frequently. Okay? All right. So now, there are specific names for polygons based on the number of sides a shape has. And we need to familiarize ourselves with this. So we're going to make a little 2-column table here. The first column is going to be titled the number of sides. The second column of the table is going to be titled name of polygon. So in other words, I'm going to tell you how many sides a shape has, and we're going to see if anybody in the class knows the specific name for that kind of shape. Number of sides, name of polygon. Okay, that's what our table is. So let's start off with the minimum number of sides a shape can possibly have in order for it to be a polygon, which is 3. We all know this. This is dumb, but we need to go over it. Yep, a 3-sided shape is called a triangle. Very good. Okay, and by the way, when we talk about the interior angles, this is a tease for later on in the lecture. When we talk about the interior angles, it's all going to be based on triangles. Okay, so a 3-sided shape is called a triangle. Anybody know what a 4-sided shape is called? Don't say square. Quadrilateral. Very good. So, if a shape has 4 sides, it is known as a quadrilateral. All right? Now, we will learn in this class, as you guys become better and better at these shapes, you will learn that there are specific kinds of quadrilaterals, like squares, rectangles, trapezoids, rhombuses, parallelograms. So there are specific types of quadrilaterals. But if a shape has 4 sides, you call it a quadrilateral. Anybody know what a 5-sided shape is called? A pentagon. Okay? Pentagon. The United States military's headquarters are in a building called the Pentagon in Virginia. Guess how many sides that building has?
5.
It's a 5-sided building. Okay? 6-sided. Hexagon. Good. Most of these are pretty familiar and relatively common. So a 6 is a hexagon. Now a 7-sided shape is pretty uncommon. Okay, so if you don't know what a 7-sided shape is, don't go home and beat yourself up for it. It's okay. Most people don't know what it is. I just happen to know what it is because I've been teaching this for 30 years. Anybody know what a 7-sided shape is called? Septagon? No. Has nothing? No. Okay, so here's what you're going to do. I'm going to teach you guys a secret right here. If you don't know the name of a shape, like a 7-sided shape, you literally call it a 7-gon. Yeah, that's for real. So if you don't know the name of a shape, or you forget it, a 7-sided shape, we will call it a 7-gon. The actual name is a heptagon. You are not responsible for knowing that. A 7-sided shape is such an obscure shape. You just don't see it much. So who cares? You know? But we should care about it because 7 is the perfect number. Number 8. An 8-sided shape, you see this every day when you come to a stop. It's an octagon. Yep. A stop sign is what is known as an octagon. This Friday night, I have a big fight. I have to step into the octagon. A little MMA action going on, okay? All right, a 9-sided shape. A 9-sided shape is a very oddly shaped shape. I don't care if you know the name of a 9-sided shape or not. So if you don't know the name of it, what can you literally call a 9-sided shape? A 9-gon. Yep. You could call it a 9-gon, but in case you're curious, the official name for it is a nonagon. That's what the official name of a 9-sided shape is, a nonagon. And then a 10-sided shape, most of you should be familiar with that name. Anybody know? 10-sided shape? A tenagon? A tengon? But you should probably know this name. How many years in a decade?
Decagon.
10, so it's a decagon. Good. So a 10-sided shape is a decagon. Deca means 10. Okay, gon means sides. 10 sides. And then you guys, anything over 10, I don't care if you know the name for it. Okay? So like a 27-sided shape. I don't care if you know the name for a 27-sided shape or not. What would you call a 27-sided shape? You would literally call it a 27-gon. Okay? Now, by the way, there is a specific name for every numbered shape. So like if you wanted to know, hey man, I wonder what a 312-sided shape is called, there is a specific name for it. Alright, but you don't have to know it. So we're just going to put n here. N means it could be any number of sides. Okay, so you would just call it an n-gon. Okay, so no matter how many sides a shape has, n, let's say n is 49, you would call a 49-sided shape a 49-gon. Okay, so we've got that right there. All right, you guys, so familiarize yourself with these. Why should you familiarize yourself with these? Because on a test, on a question, if a question says, hey, we have a hexagon, you need to know a hexagon means 6 sides. Okay? The people who write math questions expect you to know the names and how many sides shapes have. So they won't ever say, hey, guys, there's an 8-sided shape. They will say, hey guys, there is an octagon. By the way, remember, we're recording right now, so when I'm about to yell at Hunter for looking at his phone and not paying attention, this will be forever on the line for everybody to see, okay, and hear. All right, so Hunter, get up off your phone. What were you looking up? How many sides a 326-sided shape has? The answer is 326. Oh, you were looking up the name.
Yeah.
What was it?
It was some long thing. I don't know.
Yeah, it's weird.
He's bluffing.
Yeah, I feel like you're bluffing. I feel like you were playing Modern Halo, Gears of FIFA Warfare 14 version 5.2. Yeah, okay. So, part 1. By the way, everything that we've done so far was like the previews to the movie. Now we're starting the movie. So this is Act 1 of the movie. Okay, the sum of the interior angles. Sum, that, what does the I mean? That means part 1. Sum of the interior angles for any polygon. So remember at the very beginning of this lecture, of these notes, I said, hey guys, we're going to talk about polygons, and specifically we're going to talk about the interior angles. Even more specifically than that, we're going to talk about how do you find out the sum of the interior angles for any polygon. In other words, how do you find out how much do all the angles add up to for any polygon? Okay, and it's all based around triangles. Ask me why it's based around triangles. Because it is. Duh. No. It's based around triangles because we know that, and we've talked about this like about 847 times in this class so far, if I have any triangle in the world, and if I add up the 3 angles on the inside of a triangle, how much do the 3 angles of the inside of a triangle add up to? 180 degrees. So we know that angle for this triangle here, angle 1 plus angle 2 plus angle 3, the 3 measures would add up to 180 degrees. That is called the triangle angle sum theorem, okay? So you guys, when these Greeks were discovering this, when they were learning about these shapes, and when Greeks started studying polygons, then what they did was they started talking about the angles, the inside angles of a polygon. Okay, everybody knew that the 3 angles of a triangle add up to 180 degrees. So some smart aleck came along and they said, all right, so how much then would the 6 angles of a hexagon add up to? Okay, so they said, we know the 3 angles of a triangle are 180. How much would the 6 interior angles then of a hexagon add up to? What do you guys think? 180 times 2, somebody said. They inevitably said that. Okay, so they said 360 degrees. All right? Now, how did they get that, you guys? They said, here's their logical thinking. They said, look, a triangle has 3 inside angles. Those 3 angles add up to 180. A hexagon has 6 inside angles. That's twice as many as a triangle, so twice as much as 180 is 360. So the 6 angles of a hexagon have to add up to 360. The father of geometry, Euclid, that was the guy's name. He's the father of geometry. Guess what he said about the 360? He said, you're wrong. It's not 360. The 6 angles of a hexagon don't add up to 360. And everybody was like, oh, whoa, Euclid, how do you know, man? And he said, here's how you know. It's all based on triangles. He said, watch this. He said, all you have to do is just divide this shape up into triangles. Because we know every triangle is 180 degrees. Okay, so they asked him, how do you divide this shape up into triangles? So it's simple. Start at a corner. Which corner do you want me to start at?
5.
Corner 5. Okay, and then he just said, from that corner, just start dividing this up into triangles. So he said, go like this, there's 1 triangle. Go like this, there's 2 triangles. Go like this, and that's it. You can't divide it up anymore. And they go, well, you can start at corner 4. He said, yeah, but you can't cross over. So you guys, this 6-sided shape had, how many triangles did we divide it up into?
4.
So notice, this 6-sided shape, we divided it up into 4 triangles. Each triangle is 180 degrees. What's 4 times 180? This is why you have a calculator in front of you. What's 4 times 180?
720.
720.
I didn't use a calculator.
That a boy, Matt. Yeah, you should need a calculator for that. I mean, some people don't. So, you guys, he said a 6-sided shape is 720 degrees. So, in other words, he just said that if you took angle 1, you added it to angle 2, you added it to angle 3, you added it to angle 4. I'm going to run out of room, so I'm going to go down here. You added it to angle 5, you added it to angle 6. All those angles would add up to 720 degrees. And he based it on the fact that you could divide any shape up, any polygon up into triangles, all right? So what about a 4-sided shape? 1. Watch what he did for a 4-sided shape, you guys. And this is all going to lead to like a, whoa, that's kind of cool moment in the history of mathematics, okay? So then somebody said, all right, so I get it, a 6-sided shape. I cut it up into 4 triangles. How about then a 4-sided shape, okay? So they said, how much would angle 1 plus 2 plus 3 plus 4 add up to? Euclid said, simple, just divide it up into triangles. So he said, start at a corner. Which corner do you want to start at? Doesn't matter. 1. All right, let's start at corner 1. And then you could divide this up into 2 triangles. 2 triangles times 180 degrees is 360 degrees. So what does that mean? It means that any 4-sided shape, the 4 inside angles add up to how many degrees? 360 degrees. All right? And then you guys, they kept doing this. So then the next guy went along, he said, okay, smart guy. He was talking to Euclid. He said, what about a pentagon? In other words, what about a 5-sided shape? Like this. So do it again. 1, 2, 3, 4. A pentagon has 5 interior angles. How many triangles do you think we could divide a pentagon up into? 3. Start at a corner. Which corner?
2.
2, all right. And then the way you would divide it up if you started in corner 2 would be I would go 2 to 5 and 2 to 4. 1, 2, 3 triangles. Times 180 degrees. So you guys, a pentagon, what's 3 times 180? Not everybody at once. That was underwhelming. Come on, what's 3 times 180? 540 degrees. So a pentagon, the 5 interior angles add up to 540 degrees. We could do this all day. You could name a shape. I could draw it. I could divide it up into triangles, and we could do this all day, couldn't we?
9 going.
And it would be an awesome day. Come on, make it harder.
27 going.
27 gone. How about a 27 gone? Okay? So, follow along here, guys, because this is literally how it happened. I've read the books. So somebody said, hey, yo, Euclid, what about a 27 gone? And Euclid said, come on, man. I don't even know how to draw a 27 gone. Like, I mean, does anybody know how to draw a 27-sided shape?
No.
I mean, it would probably look almost like a circle. Would you guys kind of agree with that?
Yes.
But somebody goes, wait a second. You don't even have to draw the shape to figure out how many degrees all the angles add up to. And they said, why not? Somebody said, watch, look, I've noticed something. A triangle, interior angles are 180. When we had a 6-sided shape, we were able to make 4 triangles. When we had a 4-sided shape, we were able to make 2 triangles. When we had a 5-sided shape, we were able to make 3 triangles. What, Dennis?
What?
Did anybody figure out how many triangles a shape will make?
Whatever it is minus 2.
Whatever it is minus 2. So, if you have a 27 gone, how many sides is that? 20, no, how many sides? 27, so that means how many triangles, triangles would you be able to make? 25. So a 27 gone means you could make 25 triangles. Each triangle is 180 degrees. What's 25 times 180?
4,500.
Really? Wow. I believe you. 4,500 degrees. So that means if you have a 27-sided shape, all 27 angles, if you added them all up, they would add up to 4,500 degrees. Abby.
Wouldn't the formula for that be instead of 27 times 180, wouldn't it be like 27 minus 2 times 180?
So the formula to find, yes it would be. You stole my thunder, Abby. Thanks a lot. Formula to find the sum of the interior angles is this. You take the number of sides of the shape, subtract how much from it? 2. And then you multiply that by 180 degrees. So number of sides minus 2 in parentheses times 180 degrees. Okay? Or if you were reading a math book, this is what they would say the formula is. To find the sum of the interior angles, a math book would say in parentheses n minus 2 times 180 degrees. What does the n stand for in the formula? The number of sides. Very good. N in this formula is the number of sides. Okay? And you guys, that formula right there, n minus 2 in parentheses times 180 degrees, this formula will tell you how much the sum of all the interior angles of any shape would be. All right? You guys got it? Okay. Now, this is going to be kind of weird if you're watching this on the line, because you guys are about to do 3 problems on your own. So if you're watching this as a video, which you guys aren't because you're live right now, there's going to be like a pause as you guys are working. All right? So here we go. Do these 3 examples. This is practice. Let's practice doing this. All right? Practice. As Allen Iverson said, we're talking about practice. Practice. Find the sum of the interior angles for each polygon. Number 1 is going to be a picture. Number 2 is going to be words. And number 3 will just be a number. So number 1. So number 1 is that picture. It's an 8-sided shape. Number 2, find the sum of the interior angles for a decagon. And number 3, let's make it interesting, a 57gon. Find the sum of the interior angles of a 57gon. Alright? So you're doing this on your own, using a calculator if you need it. And I'll catch up with you in 1 minute. It's like Wheel of Fortune.
It's Jeopardy.
That's
It's
Jeopardy.
I like this class. You guys actually have been around the block once or twice.
It is 30 seconds.
Give me that calculator.
Yeah. Hustle. On the way. 15 seconds.
Got it all.
Okay, number 1. Now, ladies and gentlemen, you will notice on number 1, thank you for not being unnecessarily on your phones. If you use them as a calculator, thank you very much for staying on task. But otherwise, you should be off of them. Okay, so notice what I did in number 1. I don't always, but I found if I'm not sure how many sides a shape has, I number off the angles. I don't count the sides. Okay, the number of angles, if a shape has 8 angles, that means it has to have 8 sides. Ask me why I don't count the sides. Thank you for asking, Shekinah. The reason why I don't count the sides is because I'm old, and literally this is what happens. Let's say I start at this side right here and I start counting. 1, 2, 3, 4, 5, 6, and then I'm all, oh, where did I start at? Like I literally forget which side I start counting at. So I found it a lot easier for me to number off the angles. Okay, so there are 8 sides. What do I do? Right, I'm going to take the number of sides, which is 8. I'm going to subtract 2 from it, and then I'm going to multiply that by how much? 180 degrees. Okay, 8 minus 2 is 6. What'd you guys get? 6 times 180 is how much? 1080? Okay, so 1080 degrees would be number 1. All right, now, guys, girls, Zach, does this mean that each one of these angles is 1080 degrees? No. You guys would be surprised how many people tell me that. Like I go, how much is angle 2? And some student goes, it's 1080 degrees, Mr. Tretna. And I'm like blown away. Because you guys, what's the biggest an angle could possibly be? 180 degrees. So what is this 1080 saying?
All the angles.
Right. If I add it up, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 angles, they would add up to that many degrees. Okay, number 2, a decagon. I gave it to you in words. How many sides does a decagon have? 10. So to find out the sum of the interior angles, you would take the number of sides, 10, that's a decagon. You would subtract 2 from that, and you would multiply that by 180. That would make 8 times 180. What's the answer? 1,440. So in a decagon, all 10 angles would add to 1,440 degrees. Okay, number 3, a 57gon. What am I telling you? How many sides does a 57gon have? 57 sides. So you take the number of sides, 57, subtract how much from it? 2, that'd be 55, and then you multiply it by 180 degrees. Come on, what'd you guys get? This is a big number. 9,900?
Yeah.
9,900 degrees. You guys, that means if I added up all 57 angles, they would add up to 9,900 degrees. Okay, any questions on how to find the sum of the interior angles for any polygon I could possibly throw at you? No. All right, moving on. Okay, so you guys, if you understand that, Jordan, you sure you understand that? Good. I like how, Jordan, you were just explaining to Brooke how to do the problem. That was very nice of you. Okay, so now, if you understand that, now we could bump it up and we could do problems where we're solving for a variable. Okay? So watch this, you guys. We can apply our knowledge of this formula that gives us the sum of the interior angles, and now we could use it to solve for a variable in a shape. All right, like this right here. So let's draw a wonky four-sided shape. And the reason why I call this shape wonky is because it does not have a specific name to it. Like this. So that's obviously not a square or a rectangle or any four-sided shape. So you guys, if a four-sided shape is wonky like this, what do you call it? A quadrilateral. That's what you would call this, okay? All right, make the top left angle 108 degrees. So we already know that. Make the top right angle 102 degrees. So we already know the measurement of that angle. Make the bottom right angle 77 degrees. So we know those three angles. And make the bottom left angle, let's make that our variable. Okay, x? Yeah. You want to just make it x, or do you want to make it something fun like x plus 12 or x minus 8? Okay, you just want to do an x? Yes. All right, we'll just do an x. Let's just make it an x. We'll start off easy. Then we get to number 5. We'll make it a somewhat more complicated. Okay, so obviously this problem is we're solving for the value of x. Anybody got any ideas on how to do it? Abby?
You would add all the angles you know up.
Yeah.
And then divide by 2 for the x.
I liked what you said first, that you would add up all the angles you know, but I don't know about dividing by 2 part.
And then actually you would divide by 4?
I don't even know. No, you would divide by 4 if everyone was equal.
Okay.
Anybody got any ideas? 73 is your idea, Zach? Oh, you say the answer is 7. Okay, tell us how you got it.
Oh, I just added up all the angles and subtracted it by 360.
Okay, hold on. I don't know if you guys heard what he said. He came up with a number. He randomly said 360. I don't think he randomly said 360. Nia, thank you for not being on your phone. Unless you're using it as a calculator, then once again, thank you for being on your phone. So, Zach, where did the 360 come up from?
It's the sum of the interior angles.
So here's what Zach did. He used that formula. He took the number of sides of the shape, which is 4. He subtracted 2 from it. He multiplied it by 180 degrees. He used that formula. That equals 360 degrees. That's very important, that number. Because what is that 360 telling us?
That's what they all add up to.
That's what they all add up to. So that means that the x angle plus the 108 angle plus the 102